Smart Curtain. I'm here to introduce our project to the rest of the group and our progress on it. So what we have is an automated curtain system that can open and close the curtains, which are not here at the moment, but at either scheduled intervals or with your phone or computer remotely via Bluetooth. So we'll just jump right into the kind of introduction of our system. So right at the beginning right here we have our SAM4S microcontroller that is kind of the heart of our project. It has a real-time clock that we use for scheduling and handling our event system, as well as our UART to communicate with the computer. As we move farther over, we have our Bluetooth communication in this tangle of a mess of wires. It is a serial Bluetooth device, so it just transparently connects a UART connection to our computer. Amazingly, that is very difficult to do, despite it having a very simple sound to it. And all the way at the end, we have our stepper driver that is controlling our very large stepper motor just to the side. The stepper motor definitely is overkill as far as size and power goes, but it's what we had readily available, and it definitely would move a curtain if we had a curtain on the system. Attached, of course, is our drive belt. This is kind of where our weakest link is right now. It is the reason why we don't have a curtain is it doesn't have enough oomph in the belt to actually move said curtain, and also we don't have the correct teeth spacing for the drive gears, so it doesn't actually work. But it does move, so we can demonstrate the functionality. Behind the drive belt we have a series of 3 Hall effect sensors that are used to help guide the system while it is moving. So if it ever encounters one of these systems, it can make or one of these Hall effect sensors, it can make a quick adjustment and begin moving in the right direction. So actually, in just a minute, our system will actually start moving on its own to about the halfway mark. And we can kind of mess with the whole system prior to doing this. Actually, we should have moved its own. By simply, there it goes. I was going to move it, but I'll demonstrate the auto correction. So here it moved at 10 o'clock. I told it to move to 50%. If we were about to show you the software. So right over here we've got our software we use to manage the system. And give it a second. The screen's bright, I know. So here at any point we can set the position of it. So for example, if I set it to 25%, the motor then moves to approximately 25%. The system is kind of expected to have lots of error and is able to handle that. If we want to, of course, mess with it a little bit, and we move this, way over here, really trying to mess with it, we tell it to go to 0. What's really nice is it will pick up that sensor here, and it automatically corrects it. Instead of moving about 25%, it's actually going to move the full length of the curtain. So this is kind of part of the error handling the system expects. If you were to have powered the system off, it would have recognized where it was at and corrected for it. And I'll quickly show you the calibration phase of our system because it's not painfully bad. So if we just reset the microcontroller and tell it to calibrate, it'll find the first sensor and begin walking through the entire system. And by doing that, it knows exactly how many steps are in between each system, and this kind of gives it the full-blown knowledge. And that's actually all it really does from that perspective. Obviously we can kind of have fun and just set stuff, but with that we can start talking about how everything is set up and running. Oh, I've lost connection with the computer, which will cause it to be angry. Obviously resetting it is not a good idea in the middle of the drive system, but it is capable of recovering from it, which is always a good sign. The system, when it connects to the computer, it automatically actually synchronizes its time, so it just checks to make sure it's within a threshold of error. To keep the communications down, it only synchronizes about every 10 seconds, kind of with the heartbeat, not to be confused with the heartbeat bug from OpenSSL, but we can just kind of set the system and it just runs on its own. Now it does slip, and that does kind of create incremental errors. The software itself on the microcontroller communicates using JSON strings. There's really powerful libraries that make this fairly easy to do. It doesn't look terribly great, but it's a lot of code to do a lot of pretty difficult communication over the air. So with that, that is kind of the rundown of our or the basics of our software. It just schedules events in the real-time clock through once again, a significantly more complicated than it probably needed to have been system. But here we are, hard to see, but we're actually looking at the handler that handles the events. The code will be posted on the wiki for your viewing pleasure or for your great critiques. With that, that is the basis of our project for Smart Curtain. Our team is Nathan and Mia, and we look forward to seeing everyone else's projects.
Okay, so that